Hi, welcome again to my engineering channel. Today we're gonna start with a different tutorial. Okay, I decided to do some changes. By the way I'm gonna structure things, the way I'm gonna talk about things is gonna be a little bit different. So today we're gonna start talking about uh, a new tutorial of a new design. Okay, in this case, a new kind of as a machine. And I'm gonna try to make it in different videos. The first one is gonna be explain a little bit about the machine and the mechanical side. The second one is going to be um, about the pneumatical diagrams. Okay, because you can see like it is, and I'm gonna explain that it is quite pneumatic, this machine. And then we're gonna do the electrical diagrams and the programming. Okay, I made two videos of this machine before and I have deleted them just because I want to do it in the different way. Okay, so this one, as far as I want, is gonna be better. Okay, and I'm gonna explain things much better. So we're gonna start. This machine is pretty much a stamper. Okay, it just stamp a code or a part number into these boxes. Okay, the boxes not necessarily have to be cardboard, although they look like they are. In this mechanical part, or in this mechanical video, I'm not going to show any 3D design because I used this factory IO that you probably are familiarized with. It already has a lot of these components. Okay, so we pretty much just arrange some of them together and we make that machine that in reality would be quite different, but at least the configuration it is similar of what really I would want. In this case, it's going to be just a simple stamper. Okay, and that is not the main thing I want to really try with this machine. What I want to try is the fact that we're going to put a lot of elements or items that are going to be down the line. Okay, instead of before that we were running just one element and the machine does whatever it has to and then it continues, and then a few seconds later the next element comes. This one is going to simulate something more realistic. Okay, it is very common that parts that are going to be come in a mass production factory. Okay, so things are going to be coming fast, one after another one. As you can see, the gap between one and another one, it is pretty much zero. In fact, sometimes it's going to be as close as a few millimeters or even less than that. And I want the machine to be able to keep with everything, okay, the best it can. So the objective is to try to test a specific configuration for high production elements. Okay, in this case, as I said, the stamping task of the machine, it is the less important. Okay, the more important part are the most important part, or the most important parts are going to be how it handles mass production. So the configuration, okay, as you can see, is going to be two conveyors, this one and that one. In reality, I probably would use only one. It's going to have most of the first conveyor really is for the line. Okay, as you can see, like where all these boxes are going to be piling up. And the machine is going to be divided in three main areas. All right. The first area is from when it starts till the first stop. Okay. The second area is going to be between that stop and this stop, and the third area is from this stop till the end. Okay. I'm going to name the first area the entry. Okay, is when things are entering in the machine. The second area, that one to that one, is going to be in position. Okay, so now the box is going to be in position and the machine is going to stamp. And the third one is exit. Okay, is when the item is exiting and the machine is going to reset. So the next box is gonna now enter in this next area. So the main configuration is gonna be the following. Okay, I'm gonna use pneumatic pneumatics, okay, in order to stop batteries, in order to clamp, sorry, batteries, boxes, in order to clamp the boxes, in order to stamp, okay. All these three actions, they're gonna be done by pneumatics, okay. As an electrical output, we're gonna have the conveyor motors, okay, that one for sure has to be electrical, and the solenoid, that is the solenoid valves that they're gonna control these pneumatics, okay. That for the outputs, the main outputs. So the configuration that I decided is the following. I've decided to put a stop and a clamp for the first entry area, okay. The main reason is because if I use only a stop, and that one is gonna pile up, that one is gonna pile up, that one is gonna pile up, you're gonna, depending on the motor and the speed of these boxes, they're gonna be piling up and they're gonna have high inertia impacting this stop, okay. In that case, if there is a lot of force pushing the stop against the wall, between the stop and the wall, the friction coefficient, no, sorry, the friction force, okay, besides the coefficient, is going to increase by a lot, okay. The reaction is going to increase by a lot, and now it's going to be much more difficult to retract that cylinder, okay. To avoid that issue, and that could cause problems with the cylinders, I decided to put a clamp, okay. The clamp, pretty much, I wanted to clamp the second box, leaving this one ready, okay, or loose, so there is not a lot of force when more boxes are coming, and at the same time I'm trying to use the minimum number of cylinders. The other option would be using only a clamp, right? I can use only one clamp, boom. But the problem is that if the same thing, there is a lot of inertia here coming, it could happen that all this force is going to push the first box that it is clamped, but it could squeeze through the clamping cylinder, okay, and it's something I don't want. So my favorite predilectal, more typical configuration I've used for this case is going to be a stop and a clamp. You can put more than one clamp. If you put more than one clamp, now maybe you can check if really you need the stop, or the clamps, they're gonna reduce that effect of a lot of products just forcing the first one to skip the clamp or not, okay. This one is the one I like the most. You only need two and it's gonna work no matter what, okay. It's gonna work if it's low production, it's gonna work if it's high production, no problem. Then I have the same thing for the second area, okay, but here things have a small different mission. But the stop is the same, okay. Its mission is to stop the battery, okay, and put it in, just stop it exactly where it's supposed to be, okay, lengthwise. The clamp is gonna move it, it's gonna shift this battery, sorry, I don't know why I keep saying battery. This box is gonna clamp it till the rail, okay. I have to improvise with this rail because the other ones weren't working for this application. So now this box is completely in position, and now the third or the fifth, sorry, piston, which cylinder, which in this case is the stamper, is gonna stamp, boom, the part number, okay. You can put this thing in a different position depending on where you want, okay. I think this is a default place. When everything finished, now the motor is gonna continue, and then this box is gonna keep going till the end, okay. That probably it will have more machines for checking things, even maybe checking the stamping. You would have like a small camera there checking, or whatever you want, okay. Those are the most important parts. And respect to the sensors, I only need 3 sensors, these 3, one for each area. The first one is going to be for the entry area, and that is going to control probably that. The second one is going to control this area, and the third one is going to control, or is going to check that the box already is in the exit area and the cycle can restart. Other sensors that we might include are magnetic sensors for the cylinders. Okay, and I will explain which ones I think are the best and which ones they're not needed. Okay, for the rest, the machine is quite simple, doesn't have that many fancy things. Okay, and it would be a nice machine to start testing, or to start, sorry, practicing things more complex that we will, as the pneumatics, as the electrical diagrams, as the programming, as we were doing before. Okay, I don't need, or imagine that the client tells me, you don't need, since the machine is quite simple, we don't need HMI. Okay, HMI is pretty much the human machine interaction screen. Okay, and is where connected to the PLC, and you can control the machine through a touch screen. Okay, this machine is quite simple, doesn't need, the only thing that needs is the most basic switches. Okay, things that we can add is a counter. Okay, in order to count how many of these boxes they are leaving per shift, for example, and with that we could see how the production is going for that machine. Other things that could be added, which I'm not gonna, because I really don't know how to yet, connect this thing to a network, for example, or both internet or just a regular network, in order to show these things that I've been saying, for example, counting and maybe a few things more into computers, so other engineers, they can check in live how this machine is performing. Okay, as I said, just for last comment, the way I would design this machine, it would be completely different. Not completely, the main configuration where, or the number of cylinders, the number of sensors probably would be similar or the same, but the way it would look like, the way to do things is different. Okay, here I'm just probably, well, I'm not, I'm just pretty much basing whatever factory IO gives me. Okay, in the future we may make new designs, and those ones I'm gonna start making them in 3D softwares. Okay, so we can see from a mechanical design perspective how to do a machine like that. Okay, for the next video we're gonna start with the pneumatical schematics. Okay, so recheck, try to make it yourself. Okay, right now that one doesn't exist in factory IO, so I just made it. It's just a regular long conveyor, a shorter conveyor, and then we have that cylinder, or the pick and place, which I'm using as a stamper. Okay, so we won't use the second feature. Okay, the where is that? Let's say that that is the Y axis. I won't use the y-axis, I will only use the z-axis, and these clamping things. Okay, and then the regular panel. Okay, so it's very basic. Try to build it yourself, try to prepare as I do, and then you will see in the second one how do we do the schematics. Okay, for the pneumatical components.